Alright, so the first passage we're going to go over is your first individual passage, so it's passage 1.3. So we can see the passage on our page right here. And now I'm going to go straight to the questions. We don't waste our time reading in science until we need to. So this says, based on the passage, that's my locator, an individual with A positive blood could safely receive a transfusion from which of the following blood types? So which could A plus receive? So, a significant complication can occur is that the recipient's blood contains antibodies. Let's see. Transfusion, transfer of blood from a healthy person to a patient. Primary antigens are A and B. If you have neither an A nor B antigens, you're designated O. Okay, so the recipient's blood type is A positive. Okay, so an individual with A positive blood. So the recipient has A positive. So we're going to look here, although AB is a different type. But we have A antigens and positive. That means A minus, A plus, B minus, B plus. Let's see if we didn't miss something in the passage, though. A sample of transfusion compatibility, so it's not all of them. Okay. So we have basically all of them say yes for AB positive. But AB positive is its own blood type, so let's see if we're looking this up. So all RH positive blood types, that's a no, because we had some negatives in there. Maybe all blood types, but let's make sure, because we are looking at AB positive. A plus and A minus, and then A plus and B plus. So, let's see. Let's go back here. The phenotype is determined by the genotype. Okay, so we have A blood if we're A and O. So now, let's see. For centuries, a person is said to have a blood type if his or her red blood cells have a particular set of molecules called antigens on the cell's surface. The primary antigens are A and B. If a person's blood cells have neither an A nor B antigens, they are designated O. As significant is the RH antigen, which is inherited separately. That's a positive. Okay, so RH is your positives. A significant complication that can occur from giving blood to someone of a different type is that the recipient's blood contains antibodies, proteins that react with antigens, which recognize and attack any blood group not normally present. A recipient cannot safely receive blood from someone with an incompatible blood type. Okay, so we actually don't have type A on there. So A positive, what can we receive from? So let's see, B positive can't receive from the A's. B negative cannot receive from the A's. But AB positive can receive from the A's. So we know that AB positive can receive from A plus or minus and B minus or plus. But B positive can only receive from B minus or plus. Okay, so but we're looking for just A positive. We're looking for just A positive. So if AB can receive from all of them, but B can only receive from B, we can make an assumption here that A can only receive for plus or minus. So if we put all those things together, it's not all blood types. We can cross off that answer now because that was just for AB positive. And it can't be all positive blood types, so we can assume it's just A plus and A minus. So this one was difficult because it wasn't directly on the table. Right, you had to analyze it. Okay, a child with blood group phenotype AB positive could have parents of which of the following phenotype? So let's see. A child has AB positive, and so that means parents came from the AB phenotype, right? There's no real option. So, which ones are A and B? So AB positive, so that means I'm between G and I'm between H. But I can take the O's out because that's the only way we can be AB. So now, do I want A negative and B negative? Or do I want A positive and B negative? So, it doesn't say anything about our positive or negative here, so let's think about this. This is a positive, right? So let's think about like when you're factoring squares. This number is positive, that means I need to see positive reflected in the answer choice. So my answer is H. Got to change my colors for you, sorry. Alright, 15. Suppose that a patient with blood type B positive is in need of a transfusion, but the blood bank only has A plus, A minus, B plus, and B minus. Based on table 1, so that's my locator. So B positive, table 1, which of those would he be suitable for the patient to receive? So I'm going to go to table 1, and I'm going to find B positive. Table 1, B positive. So none of the A's, B positive, can receive from B minus or B plus. So, B minus or B plus, my answer is D. Alright, 16. Based on the information provided in the passage, that's my locator, the passage, which of the following blood types would be safe for any transfusion recipient to receive, regardless of the recipient's blood type? So, which of the following blood types would be safe for any transfusion recipient? So, regardless of the recipient's blood type, which means I can ignore on this table the recipient's blood type. We don't care about this right now. What blood type is yes all the way down? Yes, yes, no, so it's not A minus. Yes, no, 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 definitely not A plus. Yes, 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 B negative. So, I have a B negative right here. That's an option. And then we have yes, no, yes, no. So, based on our table, we should be able to go with B minus, but that's not one of our answer choices. B minus. So, I can assume that we're either going to keep the B or we're going to keep the minus. Okay, we're going to keep the B or going to keep the minus. So let's look at our answer choices again. We have A, B minus, which we know that's a no. A, B plus, which we know that's a no because that's an A. So we could keep the minus or we could keep the B, but we definitely can't have A in it. So that means I'm between O minus and O plus. So I can't keep the B, I'm going to keep the minus, O negative. And if you went to the blood drive that we had put on this year, you'd actually know that O negative is the universal donor. Alright, 17. Which of the following ABO blood types would not be possible for the offspring of a woman with type A and a man with type AB? So, let's see. So a woman with type A and a man with AB. So a woman with type A could make A, and someone with type AB could make AB. So, what could we not make? Well, we could make A because it has it, we can make B because it has it, and AB because it mentions it, right? So we have an A with an AB, and you don't have to do your Punnett squares, but this is mentioned, and then this is mentioned. So the only one we can't make is O. That one is just literally matching your key terms. So AB, is there an O in there? No O? Okay. Boom. And final question. 18. A physician orders a blood transfusion for a patient with A plus blood and later discovers that her patient was given O plus blood. Should the physician be confident that this is a safe transfusion? So, no, because anti-O antibodies will attack the O antigen. Our anti-RH, so they're RH matches, okay? So we have an RH match, but we have a type mismatch. Okay, so let's see. Is it safe or not? So we'll go back to the passage. Now this says, the primary antigens are A and B. If a person's blood cells have neither antigens, then there's type O. Okay, so let's see. O antigen. So let's see, I'm going to look for antigen talk. Okay, so there's antigen mentioned here, antigen mentioned here, antibodies, the O antigen, antigens. Okay, now, this says, in the difference here, there are, if there are no antigens, they have type O. So that means that we need to cross off all of the answers that have the word antigen in them. So I'm going to go here. The ones that mention O antigens, I can cross that off as an answer. So no and no. So I'm between no because the anti-RH antibodies will attack the RH antigen, or yes because it doesn't contain any antibodies. So I'm going to put my answer as J, because we didn't say anything about RH antibodies in that passage. So this is not mentioned. And this one is, there's no such thing as an O antigen here. And that is the end of passage 1.3.